Hello again, and welcome to chemistry. This is your favorite biology 103 instructor. Okay, let's begin by talking about the atom. The atom is the most basic unit of matter, or we can say it's the smallest building block of matter. And we know that the atom is created from, or made of, or can be talked about as far as on a subatomic level. And on that subatomic level, we know that there are three parts. And the three subatomic particles, can you tell me what they are? That is correct. Protons, neutrons, and those wonderful electrons. So for the protons, neutrons, and electrons, we want to examine their location. We also want to look at what is their mass weight? Okay, what is the mass? And then we want to look at the electrical charge of each one of those guys. So let's begin with the proton. The proton we know is found where? We know it's found in the nucleus. The atomic mass unit is 1.0. And then what do you think the charge is for a proton? That is correct. The proton's charge is a positive 1. Okay, let's talk about the neutron. Well, as you can see, the neutron is found in the nucleus. We know that it has an atomic mass unit of slightly more than 1. And unlike the proton, who had a positive 1, the electrical charge of the neutron is 0. So therefore we call them neutral. All right, let's move on to the electron. Now the electrons, they're located not in the nucleus. So we know that they're located in orbitals or shells. So they actually orbit about the nucleus, but they're not in the nucleus. So they're found outside of the nucleus. And again, we said that they are orbiting around the nucleus, or in these shells, okay, or electron shells as we might call them. Now let's look at the mass. The mass is very tiny, so we're just going to call it 0. And it's opposite of the proton, so it has an electrical charge of a negative 1. Because remember, a minute ago we said protons had an electrical charge of a positive 1. So electrons have an electrical charge of a negative 1. So the periodic table, what is it? I'm sure most of you have seen one before. Well, it's a periodic table of all of the elements that have been found in nature. And the nice thing about this listing of these elements and atoms is the fact that it gives us some important information about each one of them. Some of them, well, we know most of them will tell you the mass number. They'll tell you the atomic number. Some will have only the symbol. Some will have the symbol as well as the name. Some will give you, for example, electronegativity values. But anyway, let's just look at one of the elements off of that table. Okay, so here's hydrogen. And as you can see, hydrogen has the symbol in the middle, so we can see the symbol. Over here you can't really see because of my contrasting colors are not contrasted well enough, but here's the atomic mass. Oh, let's go back. Here's the atomic mass. And over here, the name of the element that you can see down below, hydrogen. Okay, and also we see an atomic number. When I want the pen to do this, It won't. Let's try one more time. The atomic number. Okay. Now, let's go on. All right. So now we want to, since we looked at that chart, we noticed that hydrogen had an atomic number of 1. So now we want to define, well, what does the atomic number stand for? What does that 1 stand for? Well, that 1 tells us the number of protons that are found in the nucleus of that atom. Okay? Again, so it's the number of protons that are found in the nucleus of an atom. So what if I said to you that atomic number never ever changes? Then what would you say to that? That is absolutely correct, because if you changed from that atomic number, we know that we've moved on to another atom or element. For example, if you have your table that's in your book on page 29, if you're looking at it, or if you have the periodic chart that I put online and you've printed it off, then you'll see that, for example, if we move from hydrogen, if we move from number 1 to number 2, then we're at helium. If we move from number 2 to number 3, then we're at lithium. So the atomic number never ever changes unless we're moving on to a completely different atom or element. Now let's talk about the atomic mass. Well, the atomic mass represents the number of protons plus the number of neutrons. So again, the number of protons plus the number of neutrons. So if you looked at the table, you'll never see the number of neutrons. So you're going to have to actually calculate this number of neutrons, okay? And we'll do the calculations in just a minute. All right, so let's say something else. It says, remember that number that we saw a couple of screens back? It said that the atomic mass of hydrogen was 1.0079. Okay, well, this number is an average because the number of neutrons can be different. Okay, so for example, let's look at carbon. Carbon is number 6, so that means that it has 6 protons. Okay, but we can have a variety of carbons. We can have carbon 12, carbon 13, for example, carbon 14. Okay, so there are isotopes, are atoms of the same element which have different atomic weights or atomic masses because they have a differing number of neutrons. So if we looked at carbon 12, we know that carbon 12 has 6 neutrons because we said the mass number was equal to the number of protons plus neutrons. So if that mass number is equal to the number of protons plus neutrons, well, we said that the atomic number represented the number of protons. So we can put in 6 for here. And then we said the mass, if you're looking at carbon on your table, then that mass is equal to 12. And we don't know the number of neutrons. So in order to get the number of neutrons, we have to do what? Exactly. We have to subtract 6 from both sides. So that's going to give us neutrons is equal to 12 minus 6 is what? 6. So what if I asked you, well, how many? So what if I ask you to give me the number of neutrons for carbon 14? Carbon 14 is telling us the mass number, so we're saying the mass number for carbon is 14. We're saying the proton number, since it's still carbon, is 6. The number of neutrons should then be what? So we're going to take 14 minus the atomic number, or the number of protons, and that's going to give us the number of neutrons. So that neutron number is what? 8. Okay, so again, isotopes are atoms of the same element which have differing atomic weights because they have different numbers of neutrons. So carbon 12 had 6 neutrons, carbon 13 7 neutrons, carbon 14, which is the other one that we calculated, has 8 neutrons. Okay, so let's get rid of, okay, so if we were to calculate the number of neutrons in hydrogen, so here is the here, as you can see, is the atomic number. Here's the atomic mass. The one thing that I didn't tell you a few minutes ago is that anytime we're working with this atomic mass number, we want to use what's called the raw. And raw stands for rounded atomic weight. So that's where those numbers come from. I was trying to write mass, and it still won't let me write mass. It only wants me to be a jokester. But anyway, nothing has anything to do with me.